হ্যালো স্টুডেন্টস, আমরা আবার ফিরে এলাম যে জায়গাটা আলোচনা করছিলাম। যে তাহলে আমাদের যেটা মনে রাখতে হবে, উই হ্যাভ টু রিমেম্বার দ্যাট রেস্ট চার্জ প্রডিউস অনলি ইলেকট্রিক ফিল্ড অ্যান্ড মুভিং চার্জ প্রডিউস ইলেকট্রিক ফিল্ড অ্যাজ ওয়েল অ্যাজ ম্যাগনেটিক ফিল্ড, অ্যান্ড দ্য চার্জ which accelerates produce electric field, magnetic field as well electromagnetic wave. Another point we have to remember that the magnitude of charge is invariant. That means the magnitude of charge is independent of the frame of reference. 2 coulomb charge রেস্টে থাক, মোশনে থাক, আমি রেস্টে থাকলেও 2 কুলম্বকে 2 কুলম্বই দেখব, মোশনে থাকলেও আমি 2 কুলম্ব চার্জকে 2 কুলম্বই দেখব। যদি ভেলোসিটি চেঞ্জও হয় তাও চার্জের ম্যাগনিটিউড চেঞ্জ হবে না। অর্থাৎ ম্যাগনিটিউড অফ চার্জ with respect to all frame of reference is constant, but magnitude of mass is not constant. Mass may vary with velocity. Mass variation হতে পারে। মাস রেস্ট বডির যা মাস মুভিং স্টেটে থাকলে বডিটার মাস ইনক্রিজ করে যায়। ভেলোসিটি যত বাড়তে থাকে মাস তত বাড়তে থাকে, আরও বাড়তে থাকে। এমনকি আইনস্টাইনের স্পেশাল রিলেটিভিটি থেকেই প্রুভ করা যাবে। কি প্রুভ করা যাবে? লাইটের ভেলোসিটির সমান যদি কোনো পার্টিকুলার ভেলোসিটি হয়ে যেত তাহলে সেই বডির মাস হতো ইনফাইনাইট। m equal to m naught divided by root under 1 minus b square by c square ফর্মুলাতে b equal to c হলে m equal to m naught divided by root over 1 minus c square by c square, that means root under 1 minus 1, that means 1 divided by m naught divided by 0, that means infinity. অর্থাৎ আমরা কোনো বডির কোনো পার্টিকুলার ভেলোসিটি কখনোই লাইটের ভেলোসিটি বা তার বেশি পেতে পারি না। এটা আইনস্টাইন স্পেশাল রিলেটিভিটির একটা কথা। তো আমাদের ওই জায়গায় আমি যেতে চাইছি না, আমার চাই সেটা হচ্ছে যে দুটো চার্জ পার্টিকুলার ম্যাগনিটিউড সেটা যে ফ্রেম থেকে দেখি না কেন একই থাকবে, চার্জ পাল্টাতে যাবে না। কি পাল্টাতে পারে? আমার আলোচনার বিষয় লেন্থ কন্ট্রাকশন। লেন্থ পাল্টায় কিনা এটাই আমার আলোচনার বিষয়। আমি রেস্ট বডির যা লেন্থ দেখি, যদি এটা মোশনে থাকে, এটা মোশনে থাকলে এই লেন্থ চেঞ্জ হয় কিনা, কি এটাই আমি দেখব। রেস্টে থাকলে যা লেন্থ, মোশনে থাকলে আলাদা লেন্থ কিনা এটা আমি চাইছি। নেক্সট চলে এসেছি আমরা ফোর্স বিটুইন 2 পয়েন্ট চার্জেস Q1 and Q2 বলে নিলাম। এর লেন্থে থাকলে কুলম্ব ফোর্স Q1 Q2 by 4 pi epsilon r L naught square, because distance between 2 point charges is L naught. Here gravitational force acting between them, because massless charge particle is quite impossible, but chargeless mass body is possible. But gravitational force is very small as compared to the electrostatic force. That's why neglecting the gravitational force here. Now electrostatic force acting between 2 point charges is Q1 Q2 by 4 pi epsilon naught r L naught square. Okay, now the force with respect to the observer who is in the rest frame, force between 2 point charges is equal to this. To an observer who is at rest in this frame, with respect to there is no relative velocity between the observer and the point charges, the only one force, only electrostatic force acts between 2 point charges, because with respect to the subjective observer these two charge particles are at rest. So rest charge particle produce only electrostatic field, electric field, and they experience only Coulomb force. Now here this is the force, gravitational force is negligible, therefore the force acting between the two charge particle who is observed at rest frame with respect to an observer in rest frame is equal to this. This is the with respect to a rest observer, this is the Coulomb force with respect to this force. Next, when the charge particle are in motion, number 2, this is step 1 নেই। আমি তার ফার্স্ট স্টেপে দেখাতে চাইলাম দুটো রেস্ট বডি, রেস্ট চার্জ দুটো যদি রেস্ট চার্জ থাকে তাহলে তাদের মধ্যে কত কুলম্ব ফোর্স অ্যাড করবে। এখানে অন্য কোনো ফোর্স নেই, কারণ রেস্ট চার্জ কোনো ম্যাগনেটিক ফিল্ড তৈরি করে না। গ্র্যাভিটেশন ফোর্স আছে কিন্তু সেটা নেগলিজেবল, যেটাকে আমরা নেগলেক্ট করে দিলাম। তাহলে পড়ে থাকলো শুধুমাত্র ইলেকট্রোস্ট্যাটিক ফোর্স হুইচ ইজ 1/4 pi epsilon naught, কিন্তু দেখাও হুইচ ইজ 1/4 pi epsilon naught q1 q2 by l naught square. Now, when these two charge particles are in motion, moving state, let two charge particles q1 and q2 are moving parallel to each other with velocities v1 and v2 at a separation of l. Or with respect to an observer, velocity of the frame, charge particle may be at rest, but the frame which is moving away from this observer, so with respect to this observer, charge particle have velocity. And another situation may arise, let these two charge particles are at rest in this frame, but observer is moving away from this or towards this. So therefore, whenever there is a relative velocity between the point charges and the observer, then another force will act between these two point charges. In addition, electrostatic force. Now, to an observer with respect to which the charge particles are in motion, a relative velocity not equal to 0, but velocity is constant. That means the observer sitting in a frame which is also inertial frame. The observer who is at rest observe this phenomenon, observe this force from inertial frame, and this observer also in inertial frame. So, with respect to this observer, the electrostatic force acting between them as well as a magnetic force acts between them, because we know that a moving charge produces magnetic field, another moving charge produces magnetic field. When two charge particles are moving parallel to each other, then they will produce magnetic field and they will interact with each other. This force of interaction have some direction which was given by Lenz formula, Lenz's law also. Now my point is that when two charge particles are moving with velocity v1 and v2, how much force acts between these 2 point charges? It has another formula. Magnetic force acting between these 2 point charges is equal to mu 0 by 4 pi q1 q2 by l square when they are separated by distance l. v1 and v2 are the velocity of 2 point charges and l is the distance between 2 point charges. Then magnetic force acting between 2 point charges is mu 0 by 4 pi q1 q2 by l square. This is l square. And also into v1 v2. This is the magnetic force. This is the magnetic force acting between 2 point charges when they are in motion. From where this formula comes out? Here, look at this figure. Start. This formula comes from this equation. We know that when two parallel current carrying conductor carrying current I1 and I2 and separated by distance R, when two parallel current carrying conductors are separated by distance R and carrying current I1 and I2 respectively, then the force of attraction or repulsion may act between them. When they are moving parallel to each other, then two wires are attracted towards each other. The force of attraction, this is called magnetic force acting between two parallel current carrying conductors. Now, force between two parallel current carrying conductors is mu 0 by 4 pi I1 I2 dl1 dl2 by r square, where dl1 and dl2 are the element of length of the current carrying conductors which are carrying current I1 and I2. Now we can write I1 is equal to dq1 by dt, because rate of change of flow, rate of flow of charge is called current. So I1 is equal to dq1 by dt. I1 is equal to dq1 by dt and I2 also is equal to dq2 by dt. So putting this value I1 and I2 dq1 by dt and dq2 by dt, and this is two terms dl1 and dl2 and also r square. Now if we divide dl1 by dt and dl2 by this dt, then we obtain dl1 by dt is equal to v1, that is the velocity of the first charge particle which produces the current I1, and similarly dl2 by dt is the velocity of the second charge particle which produce the current I2 in the second conductor. So we can write dq1 and dq2 and r square here, and dl1 by dt is equal to v1 and dl2 by dt is equal to v2. So these expressions is converted into this form. So magnetic force acting between two current carrying conductor. Actually, two current carrying conductor mean current carrying conductor. Here charge is flowing, the current flowing means charge also flowing through the conductor in the direction opposite to the direction of flow of electron. Here I1 and I2 current produced due to the flow of free electrons opposite to the direction of current. So here we can say that two parallel moving charge particle also experience this force while dq1 and dq2 charge. Let dq1 and dq2 charge are moving along these two parallel lines. So and separated by distance r. Then the magnetic force acting between these two point charges is equal to mu0 by 4 pi dq1 dq2 by r square and also v1 v2. But electrostatic force here, look at the figure. But electrostatic force when they are at rest, electrostatic force acting between them is q1 dq2 where 4 pi epsilon naught square. In this situation, here electrostatic force as well as this type of magnetic force acting between them when this phenomenon is observed by moving observer or whenever there is a relative velocity between the observer and the charge particles. So with respect to this observer, electrostatic force between these two point charges is equal to electric force acting between two point charges with respect to an observer electrostatic force acting between two point charges with respect to an observer whose relative velocity with respect to the charge particle is v will be কত এখানে চলে আসো এই অবজারভারের রেসপেক্টে চার্জ পার্টিকেল গুলো যদি রিলেটিভ ভেলোসিটি থাকে তাহলে এই ইলেকট্রোস্ট্যাটিক ফোর্স হিয়ার দিস ইজ কল্ড ইলেকট্রিক ফোর্স দ্যাট ইজ ইলেকট্রোস্ট্যাটিক ফোর্স and in addition magnetic force appear to act between the two point charges. So electrostatic force as well as magnetic force acting between two moving charges, because electrostatic force is always exist, but when the two charge particles are in motion, then magnetic force also acts between them when there is velocity. But when they are at rest, v1 and v2 become 0, then there is no magnetic force acting between them. But here v1 and v2 are not equal to 0 with respect to the observer. So magnetic force acting between the two point charges is equal to this. And electrostatic force acting between these point charges is 1 by 4 pi epsilon naught q1 q2 by l square. With respect to this observer, let L be the distance of separation between two point charges. So this is the electrostatic force and this is magnetic force. If these two point charges are at rest in this frame or moving with same velocity v with respect to this observer, or these two point charges are at rest but observer is moving away or towards the point charges, then the relative velocity of the charge particles with respect to this observer will be same. So this is v. If these two charge particles are at rest, then when the observer is moving along this direction with velocity v, then the charge particles are moving away from the observer with velocity v. Just like when you go travel in a car or a moving train, then we observe that the trees, platform and other pillars are moving on backward side with respect to the moving car. So similarly, when E is moving, then the rest charge particle will be in motion with respect to the observer. And another situation may arise. Let this observer is at rest, but this two charge particle is moving away from the observer or coming towards the observer. Then there is a relative velocity between the observer and the charge particle. So whenever there is a relative velocity between the observer and the charge, there is a magnetic force acting between the two charged particles with respect to the observer. So this magnetic force is equal to mu 0 by 4 pi q1 q2 by L square into v1 v2. But here v1 equal to v2 equal to v, let. So on v1 equal to v2, let this two charged particle is at rest in this frame, but observer is moving towards the charged particle or away from the charged particle. Then velocity of this charge with respect to the observer is v, and velocity of this charged particle with respect to this observer is also v. So v1 equal to v2 with respect to this observer. So we can write down the v1 equal to v2. So the expression is in the form mu 0 by 4 pi q1 q2 by L square into v square. Now another point. Now we first compare this equation, these two forces, electrostatic force and magnetic force. Electrostatic force Fe is equal to 1 by 4 pi epsilon naught q1 q2 by L square with respect to this observer, and magnetic force acting between two charged particles with respect to this observer is mu 0 by 4 pi q1 q2 by L square into v square also. So total force acting between the two charged particles. So total force acting between the two charged particles with respect to this observer is electrostatic force, gravitational force and magnetic force. But gravitational force is negligible. Here gravitational force also negligible. Here, so here we can neglect this gravitational force. So only this is negligible. This is negligible. Here, this is negligible. So the total force acting between the two point charges with respect to moving observer F is equal to electrostatic force, which is equal to q1 by 1 by 4 pi q1 q2 by L square, and magnetic force acting between the two charged particles Fm equal to mu 0 by 4 pi q1 q2 by L square into v square. This is magnetic force. But this magnetic force acts opposite to the direction of this force. Why? Because according to Lenz's law and other electromagnetic theory, we know that the cause which produce the electric field, electromagnetic wave, which produce the EMF or etc. The cause of production of EMF, cause of production of electromagnetic wave, cause of production of force, etc. For which electromagnetic induction occurs. According to Lenz's law, it opposes the cause of induced EMF. According to Lenz's law, direction of induced current, direction of induced EMF is in such a way that it opposes the cause of EMF produced. So, whenever there is the relative velocity between these two point charges, then this is the cause of production of electromagnetic force. So, according to Lenz's law, this force is produced due to the relative velocity between the observer and the source. So, this force acts opposite in direction. So, we can write down this. I don't know whether it is correct or not. Please inform me if there is any misconcept. F is equal to Fe is equal to Fe minus Fm. Fm means magnetic force. So electrostatic force acting between the two point charges with respect to moving observer is this, and magnetic force acting between the two point charges with respect to this. These two forces acting between the two point charges with respect to this observer, but only electrostatic force acts between the two point charges with respect to the rest observer, but with respect to the moving observer, electrostatic force as well as magnetic force acting between them. How much magnetic force is acting between them? Fm is equal to mu 0 by 4 pi q1 q2 by L square into v square. Now we compare this magnetic force with the electrostatic force, electric force. Now divide this equation by this equation. We can write down the formula. We can write this formula mu 0 by 4 pi q1 q2 by L square into v square, and divide this equation. mu naught 4 pi cancel out, q1 q2 by l square cancel out. So only mu naught and divide in term the epsilon naught coming out on the numerator. So mu naught epsilon naught into v square. So mu naught epsilon naught v square is the ratio of the magnetic force and electrostatic force. But we also know that the velocity of light, in free space, c is equal to 1 by root under mu naught epsilon naught. This is the velocity of light in free space, where mu naught is the magnetic permittivity, epsilon naught is the electric permittivity of the free space. Now, putting the value of mu naught epsilon naught is equal to 1 by c square in this equation. C squared is equal to 1 by mu naught epsilon naught, and therefore mu naught epsilon naught is equal to 1 by c square, mu naught epsilon naught is equal to 1 by c square. So putting this value in this equation, so from equation 3, dividing the equation 3 by equation 2, we get Fm by Fe is equal to epsilon naught mu naught v square. Epsilon naught mu naught is equal to 1 by c square. So this is equal to 1 by c square. So putting this value, we get v square by c square. This is the ratio of the magnetic force and electric force. We know that velocity of charged particle is less than the velocity of light. That's why the ratio is less than 1. Therefore, magnetic force, velocity of charged particle is less than the velocity of light. That's why magnetic force is less than electric force, or electric force is greater than magnetic force. Electric force is much greater than magnetic force. So magnetic force is equal to V naught V square by c square times of electrostatic force, electric force. This is the main formula. Magnetic force is equal to V square by c square times the electric force. Is the formula. When we got this formula, to discuss the Coulomb force and magnetic force acting between the 2 point charges in our students, my son Somo Basuli and other students who are coming yesterday to give some information about electrostatic force and force between 2 point charges. Then we already discussed these two forces, electrostatic force between 2 point charges and magnetic force acting between 2 point charges. Magnetic force in moving state and this is electric force in moving with respect to moving observer, and this is magnetic force acting between the 2 point charges with respect to this observer. And comparing these two forces, we get electromagnetic force is equal to V square by c square times of electric force. From this expression up to this level, this is the level up to 10 class. This is the level of the 10 class. If any student know this formula, then he can derive this formula. Now, my point of view is to explain according to me, length contraction can be calculated. This formula can be obtained with these simple two formulas. How length contraction formula L equal to L naught root of R1 minus V square by C square is coming out. When this formula is already derived, then I think that there is some relation between the length, force and velocity of light and the velocity of charged particle, because V square by C square is well-known term in famous Einstein's famous E equal to mc square, m equal to m naught by root over 1 minus v square by c square, t equal to t naught divided by 1 minus v square by c square, etc. So we can apply this concept in case of to derive the length contraction formula. Now let's go to this discussion. Now there is a simple two equations. So we have done two forces, electrostatic force and magnetic force acting between 2 point charges. with respect to the rest observer only electrostatic force acting between them, and with respect to an observer electric force as well as magnetic force acts between them. And this magnetic force and electric force are in opposite direction. That's why F is equal to electrostatic force plus magnetic force in opposite direction, whose magnitude is V square by C square. Putting this value here. So, taking common Fe, we get the formula F equal to, this is the force with respect to the force acting between the two charged particles with respect to this moving observer. Fe into 1 minus V square by C square. This is the force acting between 2 point charges with respect to the moving observer. Now, we know that since two observers are in inertial frame, the observer who is sitting in this frame at rest is also in inertial frame, and looking this observation or calculate this force acting between these two charges, and these phenomena if observed by the observer which is in motion, then the same phenomenon observed from another frame who is in motion, or when there is a relative velocity between these 2 point charges and this, he experienced two force acting between the 2 point charges. One is electric field, another force, another magnetic force, and the total force acting between the two charges is theta. This. Now my question is, if there is only electrostatic force acting between the two charged particles, and here is electrostatic force as well as magnetic force, how these two forces are adjusted? Because since two observers are in inertial frame, that is non-accelerated frame, then the force acting between the two particles with respect to the both observer will be same, because with respect to inertial frame of reference, that means the frame which is at rest or moving with uniform velocity, force acting between 2 point charges or force acting between any body, force act on any body is a real force. If there is an accelerated frame, then another type of force will come which is called pseudo force. But here no pseudo force arises, because these two frames are at rest. This frame is right and this frame is moving with uniform velocity. There is no acceleration at all. So we cannot say that the observer is in non-inertial frame. So with respect to the observer which in inertial frame, force acting between the two charges with respect to the rest observer is equal to the force acting between these two charges with respect to the moving observer with constant velocity also. But my question is, how these two forces are adjusted? Here only electrostatic force acts, but here electric force as well as magnetic force act. If this electric force acts between these two charged particles with respect to this observer, then in additional force acts between these two charged particles which can disturb this formula. So there is another term. How these two equations are adjusted? Because this force is equal to this force, but there is a two term. So we can match these two forces by assuming that let there is two charged particle. Let there is a two charged particle Q1 and Q2 are at rest. Observed from a rest frame. Observed from a rest frame in observer. Then electrostatic force acting between them is only this. And when this phenomenon is observed by another person from another moving frame, then force acting between them is electrostatic force as well as magnetic force. Electrostatic force plus magnetic force, which is equal to V square by C square Fe, that is Fe into 1 minus V square by C square. So this is the force acting between 2 point charges with respect to the moving observer. But these two observers in inertial frame, this observer is rest and this observer is moving with constant velocity, but these two frames are inertial. So force acting between these 2 point charges observed by this person is also equal to force acting between the 2 point charges with respect to the moving observer. So if not must be equal to F. Since two observers are in inertial frame of reference, so there is a force acting between two particles there is the same force acting between the two particles with respect to both observers. Since two observers are in inertial frame, that is a non-accelerated frame, there is no acceleration, then the force acting between two particles with respect to both observers will be same. So equating these two forces, this is this force, we can write Fo is equal to F. Force acting between two point charges with respect to the rest observer is equal to the force acting between the two point charges with respect to an observer which is moving with constant velocity, that is non-accelerated frame. This is also equal. So equating these two force and putting the value F and F, putting this value, we get Fo equal to Fe into 1 minus V square C square, and Fo is equal to this, and Fe is equal to this. Fe is equal to 1 by 4 pi epsilon naught calculated by L square. So 1 by 4 pi epsilon naught L, 1 by 4 pi epsilon naught Q1 Q2 by L naught S square is equal to 1 by 4 pi epsilon naught Q1 Q2 by L square into 1 minus V square by C square here, because there is no space. That's why I write this term below the equation. Now cancel out 1 by 4 pi epsilon and 1 by 4 pi epsilon cancel out, Q1 and Q2 also cancel out. So 1 by N naught, here only 1 by N naught is square. 1 by N naught is square is equal to 1 by L square, 1 by L square into this term, into 1 minus V square by C square. Now arranging these two terms, let L square is equal to L naught square. So we can obtain this equation. Here written here, it is written here, it is written here. So look at this equation. L square is equal to L naught square into 1 minus V square by C square. So if we take the square root, then L is equal to N naught under root of 1 minus V square. So L is equal to N naught root over 1 minus V square by C square. This is nothing but the equation of length contraction, which was already given by Sir Isaac Newton. This is the famous formula. There are another formula also, E equal to MC square, and this is my approach to derive this formula in new method, new concept of physics. According to me, this formula can be derived